Hey guys, welcome to my channel. I'm LeetCoder. If you guys are new here, I pretty much do LeetCode style questions and explain things in the simplest way possible. Today we have a pretty interesting problem that I'm very excited about. So let's go ahead and read the problem statement, okay? It says, suppose we have an array of length n, right, sorted in ascending order, is rotated between 1 and n times, right? It says, for example, array num 0, 1, 2, 3, 4, 5, 6, 7, right, might become 4, 5, 6, 7, 0, 1, 2, right? It means it was rotated 4 times, right? Because 0 was that index 0, right? And then shifted 4 times, right? Rotated 4 times. 0, 1, 2, 3, 0, 1, 2, 3, 4, right? Index 4 now. So it's rotated 4 times. So likewise, no 0 is rotated 7 times. Yeah, so if we add 0, right? So we had 0, 1, 2, 3, 4, 5, 6, 7, right? That means it was shifted 7 times. So that's what they're trying to say. They say that an array is rotated a of 0, a of 1, right? Up to a of n minus 1, right? If you rotate that one time, we get a n minus 1, right? Which means that the last element, if it's rotated, right? If we rotate the array only once, right? The last element will be the first element, right? Just like 7, if we rotate 7, right? If we rotate this array one time, right? 7 will be at the beginning, right? Of, and yeah, that's pretty much what they're saying right there. Instead, the array is unique. I mean, the elements in the array are they're unique, so we don't have to worry about any duplicates, right? So when we're crafting our algorithm, we don't have to worry about that, right? So we see we got a couple examples, right? All right, and this is the array shifted, right? 0, 1, 2, 3, right? And then we know 1 is gonna be the lowest one, right? Let's looking at this, we could simply do that, right? Just like this one, 0 is the smallest one, and then this one, 11 is the smallest one, right? So the easiest way of going about this guy would be to do a linear loop through the array, right? And then as we're looping through, guys, we would keep track of the minimum, right, with a minimum variable, and then we would update that every time we encounter a number that's smaller than the previous minimum that we've seen before. I'm saying, so this is the more straightforward to do it, the easiest way to do it, right? So now there's a better way of going about it, guys. They said the thing's sorted, right? Even though it's rotated, it's still sorted. You know what I'm saying, so we can apply a binary search, right? It's gonna be very, very good for us, right, in solving this problem, guys. So what we're gonna do, guys, that's gonna be very clever in solving this, right? So every time, right, we're gonna calculate the midpoint, right? So remember, I told you guys about the binary search, right? So if you haven't seen my video on binary search, I highly suggest you guys check it out. Something should pop up there. You guys should go check it out. All right, cool. So now so every time we calculate the midpoint, right? So 5 is at the midpoint now, right? So we would so the left is at 3 and then the right is at 2, right? So the midpoint is this, right? So we check, right? There's 5. So we would do a comparison, right? It's 5. The midpoint, right? Is it greater than the element that the right's pointing at, right? Which is initially the rightmost element, right? The last element in the array, right? We do that, right? So that's 5 is indeed greater, right? It is greater. So that's not correct, I'm saying, because in a regular sorted like array, right, that's not shifted, right, all the numbers to the right are bigger than all of them to the left, right? You can see 1 smaller than 2, 2 smaller than 4, 4 smaller than 5, I'm saying, as you go, I'm saying. So if you do any comparison, 1, so 1 is definitely going to be smaller than the rightmost element, right? So now with that trick that I told you guys, right, so we check 5, is it greater? Yeah, 5 is greater, right? So we know that this part of the array is sorted, what I'm saying. So it's been rotated. So now the search space is going to be between anything after the midpoint, I'm saying. So that's how we come up with the conclusion, guys, what I'm saying, by asking those comparisons that we're going to do, right? So we're going to go through a couple examples. It's going to be a lot more clearer, I'm saying. So let's go ahead and do it real quick. So I'm pasting in the examples real quick, and yeah, let's go ahead and do it, right? So now those are the indices, and then those are the actual numbers, right? So that's just this example, right, that we're doing, okay? So we got the left and the right boundaries, right, that we talked about. And every time we're gonna calculate the midpoint, right? So now the midpoint is gonna be calculated by doing 6, 0 divided by 2. So 3, right? So next 3, right, which is the number 7. So now, so now, guys, the thing that we're going to do, right, it's going to be very, very important. We're going to, so remember, when we calculate in the boundary search video that I did, right, we check the midpoint and we, depending on the target, we would go left or right, right? So now we need to, this is a modified boundary search, what I'm saying. So now the question that we're going to ask it, right, is, because we're trying to find the minimum, right? The question that we're going to ask it is the middle element that I'm pointing at, right? Is it greater than the rightmost element, right, in my search space? What I'm saying. So whatever element that the right is pointing at, right, is the middle element, is it greater than that element, right, that the right is pointing at? If it is, right, so right now the right is pointing to the last element of the array, right? So 7 is greater than 2, right? So now, you know, this part of the array is sorted, what I'm saying. So we don't have to worry about it. So now we would go to, so we know that the smallest element, right, has to exist between mid plus 1, because 7 is greater than 2, right? So we know that 7 is not going to be the minimum, right? So the minimum has to exist on my right side, what I'm saying, since 7 is greater, what I'm saying, than 2, right? So it'll be any element after me up to the last element, right? So now we update the left boundary, right? That's how we cut down the search space. So now we're not even considering those numbers anymore, right? They're out of the question, you know what I'm saying? Which is very, very good. So now we're gonna recalculate the midpoint again, right? So now the search space is only this small array, you know what I'm saying? Well, we had a big array now, the array is small now, I'm saying. So now we do the same thing, right? We calculate the midpoint, right? 6 plus 4 is 10, right? 6 plus 4 is 10, right? Divided by 2 is 5, right? So next 5, right? We check 1, right? Is 1 greater than 2, right? Nope. 1 is not greater than 2, you know what I'm saying? Because, you know, I told you guys the midpoint, we always compare it with the element that the right pointer is pointing at, right? Which is, you know, currently the last element in the array, right? So we check if 1 is not smaller, right? So now, since it is not, no, 1 is not bigger than me, right? So now we know that the smallest element, right, in the array, right, has to be between all the numbers from the left up to the middle element, right? Because that might be the issue might be in, right? I'm saying. So we would update the search space to be between only those two numbers now, I'm saying. So we would get rid of that. Right? So now it gets reduced, right? So now we did two comparisons. So this is gonna be the last one, right? So we check, right? We calculate the midpoint, right? 5 plus 4 is 9. 9 divided by 2 is 4.5. Truncate the decimal, we get 4, right? And we check, right? Is 0 bigger than 1, right? Nope. It is not bigger than 1. So now we update the search space to equal to that, right? So now we would exit out the while loop because, you know, the left and the right point to the same number. So we exit out the while loop and then return whatever number the left pointer is pointing at, right? Which is 0, which is indeed the answer that we're looking for, right? So let's just do this one real quick, all right? So it's going to be a lot quicker since we know the question that we're going to ask, right? So we calculate the midpoint. The midpoint 3 plus 0 divided by 2 is 1.5. Truncate the decimal, all right? I'm saying. So we see to find all the, oh God. So now, right, what we do, right, we do 13. Is 13 bigger than 17? No, right? It's not bigger than 17. So we cut down the search space. All right. So now the search space is smaller now, I'm saying. It's not bigger than 17. So we know that the smallest element is going to be between the left boundary up to the middle element, right? So that's how we do it, I'm saying. All right, so now the next thing that we're going to do, right? We ask ourselves the same question, guys. We calculate the midpoint, right? 1 plus 0 divided by 2, 0.5, truncate the decimal, index 0, right? So we calculate the midpoint, right? So now we do the same question, guys. Is 11, is it greater than 13? No, it's not, right? So the right boundary, I told you guys, you know, it's gonna go update to be the mid, exactly where the midpoint's pointing at, I'm saying. Exactly. So it point exactly, right? So since they're pointing at the same number, we exit out the while loop, and then we return whatever number the left pointer is pointing at, right? Which is 11, which is indeed the smaller, the minimum, the smallest number in the array, right? So let's go ahead and implement the algorithm really quickly, okay? Let's do it quickly. So we do so int left, right? And then we do int right. So int left is pointing to the first element, right, which is this one, right? And int right gets updated to equal to num length minus 1, right? Then we have this while loop, guys. You know, this is the same thing as the last problem that I did, guys. You know what I'm saying, this is a modified binary search. You know what I'm saying, there's a lot of variation. So yeah, so we calculate the midpoint, right, which is the m that I was doing right here. Right? We calculate the midpoint by doing this, right? This is a good formula to have, right? Because it helps us with integer overflow. I'm saying, make sure you mention that in interviews. All right. So we do that, guys. I'm saying we're gonna ask those questions that we talked about, right? So to decide if we should go left or if we should go right, right? I'm saying, as you guys can see, right, the binary search is very efficient, right? We did only 3 comparisons to find our answer that we're looking for this example, right? Saying instead of going through the whole array, all right, checking all 6 numbers, we only did, I'm saying, 3, which was a lot better. I'm saying, so now we're gonna decide to go left or right, right? So num's a mid, right? If that number, right, the middle element is greater than the number that the right's pointing at, right? The last element in our search space, right? If it is, right, if it's greater, I'm saying, we're gonna have to go to the right, which is done by doing left is equal to mid plus 1, right? And then now we do the same thing, guys. I'm saying, else if it's not, right, if nums are made smaller than the number that the right's pointing at, right, we what we do we update the right variable to equal to mid, right? So the small element is going to be between left up to mid. What I'm saying, so that's why we do that. So and after we do all of that, right, we simply return nums of mid, right? No, nums of left actually. We return that. All right, whatever the number the left's pointing at, right? So I think we should be in pretty good shape. So let's try to run these small test cases really quick. All right, cool. We passed that small test case. Let's see if we pass all the test cases, guys. You know what I'm saying, perfect. We're able to pass all the test cases, guys. Now I want to thank you guys for taking the time to watch this video. If you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe because I'll be doing a lot of other videos just like this one. I want to thank you guys for taking the time to watch this video, and I'll see you guys in the next one.